All right, hello everybody. Welcome to the very first Deep Astronomy Live event of 2016. I say this is the first of 2016. I hope it's not the last. I've been wanting to play with this live feature event on my YouTube channel for a while, and so I am giving it a shot here. I've done a few hangouts and stuff on this channel, but this is the first time I've tried to do this alone using some other software, and so we're going to see how this goes. There's been a lot of changes in Google Hangouts and Hangouts on Air, so I wanted to try this approach as well. So for 2016, I thought I would do this. My name is Tony Darnell. For those who don't know who I am, I run the Deep Astronomy channel as well as Space Fan News, and I also do various hangouts of different kinds. And what I wanted to do, and the reason for my doing this live stream tonight, is in addition to sort of experimenting with the new technology, I also wanted to kind of take a glimpse into what might be happening in deep astronomy news, things that space fans might be interested in 2016, because I was going to make a Space Fan News video about it, but it got too long, and so I had to cut it short, and I only did what happened in 2015. So I thought I would do 2016 here. So welcome. There's really only one or two ways you can interact with me. I'm hoping that people will be watching this soon and can leave some questions and comments. There should be a live chat feature on the watch page of YouTube, and if you enter in comments there, you should be able to say things to me. Let me just pull that up real quick and make sure I can see people. Somebody named One Way Ticket is saying hello, so there we go. So yes, if you would like to ask a question or make a comment, as long as it's not too rude, I might say it on the air, but we'll just have to see how it goes. All right. For those of you who don't know who I am or what this channel is, there's a lot of changes that have been happening or going to happen coming forward. We generally do space videos, and I've been doing them since 2006, and we sort of branched out into Space Fan News. And the reason I bring that up is because Space Fan News is celebrating its 4th anniversary this year. I started it 4 years ago this week, and the reason I know that was because the American Astronomical Society meeting always goes on in the first week of January. It's going on right now, and I'm not there, but this was born out of kind of putting out some of the news that was coming out of AAS. That's how Space Fan News was born, and then I just sort of kept going after that. And I can promise you that this week's episode of Space Fan News will have a lot of AAS stuff in it, so look for that coming forward. So what am I excited about for 2016? Lots of things coming up. Most of it is either related to JWST construction, the James Webb Space Telescope construction, or it's planetary stuff that's going on within our solar system. And so I'm excited about a lot of this stuff. I just gave you some opinions and reviews of what I thought a lot of things happened in 2015 that were cool and great. And many of you are going to learn that the more you watch this channel, the more you're going to discover that I kind of have biases that many people don't have. For example, almost everybody cares about the news from Pluto. I actually don't. And so, that's just the way it is. I mean, I think it's interesting, and I think it's great that we're going to Pluto, but I don't really care all that much about it. And so I don't really talk a lot about what's going on within our solar system, although there are some things happening this year that I am going to mention here in this little broadcast that I'm doing for you now in just a minute. So let me just sort of see how we're going. Good. We've got a lot of people coming in on the chat window. That's great. Hi guys, Bulgaria, hello, and Liverpool. Yay! Guess what, Liverpool? I am in the UK right now. I'm actually in the northeast, up near Newcastle. It is raining, wet, and cold here. It's not like my home Florida, so I just wanted to let you know that. Anyway, it's a big change for me climate-wise. So a lot of you guys are asking questions, some of which I am going to get to. How old am I? Oh man, I don't know if I want to answer that. How old do you think I am? And then I'll tell you how old I am. How about that? We'll try it that way. Okay, so Anybody who knows anything about me knows that I'm a Hubble hugger of the first degree. I love the Hubble Space Telescope and everything that it comes out of it, all the images, all of the discoveries. I do Hubble Hangouts every week with Carol Christian and the Space Telescope Science Institute. So the big news of things that I want to talk about coming up this week, first up has to do with the James Webb Space Telescope. Now bear with me while I pull up something here. I want to see if I can get it. Yeah, here we go. Okay, so here, see if I can do this. We pull this, get rid of that, and go here. Now you should be able to see this is jwst.nasa.gov. It's the main web page for the NASA James Webb Space Telescope, and as you know, they're building it right now. It's being contracted by a company my good friend Dr. Alberto Conti works at. He's at Northrop Grumman. They are the main contractor, but it's being built right now. And just last week, they were announcing that they had that most of the mirror segments have been put on the primary mirror. Now, there are two webcams. This is a live webcam, Webb with two B's, going into the clean room at Goddard. This is webcam 1. This is webcam 2. It's a little bit closer view, but if you look close and you go to this, you can go to this yourself and see what I'm talking about. jwst.nasa.gov. Here, let me just give you the link in the chat box too, so you guys can see that. Here's the link where you can go. You can click on it. I think it'll let me post URLs. I tested that earlier. Yeah, it's in the chat box now. Just go there and follow along. If you look closely, you can see that almost all of the mirror segments are on here except for the two in the outermost parts. This is the objective lens. For those of you who don't know, the James Webb Space Telescope is 100 times more powerful than Hubble. Very, very large. It has 18 mirror segments. All are going to be mounted here, and most of them are on there now. So they're being put on now, and it's really cool because they're building it with all kinds of really great technologies that had to be invented. So what's coming up in 2016 for hang on, I'm playing with all of this again. So what's coming up with 2016 for the James Webb Space Telescope is they're going to be spending a lot of time working on the primary and the secondary coupling. This is the part of the telescope that acts as the optical tube assembly. They're going to integrate those this year. That's coming up in 2016. Also, they're going to connect it all to the Integrated Science Instrument Module, the ISIM. That is coming up now, and that's also going to happen. That's the big case that's going to hold all of the science modules, the NIRCam, which is a near-infrared camera, the NIRSpec, which is a near-infrared spectrograph, as well as the fine guidance sensors and all these other things that are going to be mounted there. So that's going to happen this year, but most importantly, and the thing I'm really psyched about, is they're going to attach all of that to the sun shield. And the sun shield is this big canopy thing that's going to be attached to the JWST, which will protect it from which will allow the telescope to get very, very cold. So that's coming up in 2016. I'm really psyched about it. Another big news item coming up this week. Let me pull up the thing if I can, and that is, if you watch Deep Astronomy channel very much, then what you will have noticed is that every month I do a hangout called Future in Space Hangout, and we had the scientists on board, the team who was talking about LISA Pathfinder, and LISA Pathfinder was launched in December of 2014 or 15, just last year, and it is. I put the link to that already in the chat box, so go ahead and click on that. They launched it on the 3rd of December, and now it's on its way to a place called the L1 point. And the L1 point is a spot in the orbits of the solar system. Hang on, I'm still clicking buttons here. The L1 point is an area much like the L2 point where JWST is going to go. You have the Earth going around the sun. On either side of the Earth are these spots, one close to the sun, one further from the sun, that follow along the Earth as the Earth goes around the sun. And those are called the L1 point. That's the point close to the sun, and the L2 point is the point further away from the sun. Well, LISA Pathfinder is going to the L1 point between the sun and the Earth. It's about 1.5 million kilometers away, and it's going to look for gravitational waves, and it's going to test the technology that's going to look for gravitational waves. Anyway, they launched it successfully in December. In March, it's going to get to the L1 point, and that is going to be cool because they're going to start doing science then. And also look for this channel where I will have Alberto and the scientists back when they start getting science data. No one's seen a gravitational wave yet. And so we have observatories on the ground trying to find them, and we have now with this we're trying to put an observatory in space called LISA, the the laser interferometry. Oh my God, I forgot it. Space antenna. Phew, almost forgot it. That's LISA, and it's going to be designed to. Basically what they do is they have interferometers. These are laser beams that point at each other, and if space time ripples even a little bit, then they'll be able to detect it with the interference of the laser beams. And LISA Pathfinder is going to test that out and watch the hangout. We did it just last month on December 17th, I believe it was. Just watch it. It's on this channel, and you'll learn all about what they're doing. And I want to look for it again in March. That's the next big thing I'm excited about in 2016. Let me go back here. Let me see how we're doing. I just worry about how complicated JWST if something is to go wrong. That was from Tonic Wine 999. You know something? I was too. And if you watch the Space Fan News I did a couple of weeks ago, where I talked about the anniversary of SOHO, do you know what? We've actually had a telescope in space that cannot be serviced and very complicated since 1995. So for what is that? 20 years now. We've had a space telescope that is also at the L1 point. It's going to the same place that LISA Pathfinder is going. We've had it up there for 20 years, not a single servicing mission, and we only lost contact with it once, I think in the early 2000s, or maybe it was the late 90s, I forget now. But they did lose contact with it at one point. But here you've got a space telescope getting bombarded by solar radiation at the L1 point, and it lasted 20 years. So I used to worry about the same thing. When we launched JWST at the L2 point, 1.5 million miles the other way, the L2 point from the Earth, how are we going to fix it if anything goes wrong? What if the space antenna, or what if the heat shield, I'm not supposed to call it a heat shield, sun shield, doesn't deploy? What if the big giant primary doesn't unfold, because the whole thing is getting folded up into a rocket? What if it doesn't unfold? What if something breaks? And I can tell you, I have talked with the chief engineer at Northrop Grumman, John Ehrenberg. I've talked with Scott Willoughby, the guy in charge, one of the vice presidents at Northrop Grumman, who has got a lot of space experience. And basically, do you know, they test every single nut and bolt that ever goes onto these things rigorously. They're going to take JWST. Once it's all put together, they're going to fold it up, and they're going to ship it to Johnson Space Flight Center, where we have this giant cryogenic vacuum chamber. It was used for the Apollo program. They're going to put JWST in there. They're going to unfold it in the vacuum chamber at temperature, and they're just going to do that for a while. They're just going to work it out and see. And then they're going to turn it upside down and do it again, because unlike in space, there's gravity on Earth. And so the heat shield, in order to make sure, I can't keep calling it that, the sun shield, may deploy fine with gravity pulling on it this way, but if you turn it upside down, it might get hung up. So they're going to turn it up. They're going to turn it in different positions to simulate the conditions it will have in space. So I'm actually pretty confident. I used to worry about that too. The Hubble Space Telescope, on the other hand, has been up there for 25 years. This past year, 2015, was the 25th anniversary. It was launched in 1990 in April. But it had the advantage of being able to be serviced by the space shuttle. It's in high Earth orbit. So we went up there 5 different times to fix Hubble. The last time was in 1990, and now Hubble's a brand new telescope. So yeah, I mean, I share your concern about JWST not working once it gets up there, but I'm pretty confident now. We've got this is a solved problem. We've done it with SOHO. SOHO was the solar and heliospheric observatory that was designed to look at the sun back in 1995. No one serviced it a single time. It's still up there right now taking data. I can't believe I'm getting a phone call. Okay, hang on, guys. I'm really sorry. That's really not cool. All right. I'm sorry about that. Go away, please. Okay. All right. So, thank you. Okay, so that was a good question, by the way. I'm glad you brought that up. That was a good point. Okay, so we got Lisa Pathfinder coming up in 2016. We've got JWST. Lots of things happening throughout the year on JWST. We will have lots of Hubble Hangouts throughout the year on various milestones throughout JWST as well. Okay, the next thing I want to talk about coming up in 2016 is Juno. Some of you are already asking about this. In July of 2016, let me just pull up this little web page Rooney here. This is going to happen. Juno is a probe that was currently on its way to Jupiter, and it will arrive in July. And if you just do a search on Juno, you'll be able to go to this website. It's a NASA site. It's going to do a lot of cool things. It's got probes and all kinds of spacecraft that's going to be trying to look into the origin and evolution of Jupiter. It's going to go in. It's going to look underneath the cloud cover, and it's got lots of cool different instruments that are going to be on board. Let me see if I can click on that part here. How do you like watching me surf the web? Isn't this fun? Okay, so there's lots of bits and pieces about what it's going to do. But July in 2014, or July of next year, or this year, 2016, it gets to Jupiter, and that's another big thing I'm kind of excited about. Another thing coming up, what was I going to say? Oh, the Schiaparelli mission. I actually don't have anything up on that. That's coming up in. That's coming up this year as well. In March, I believe, the Schiaparelli mission arrives on Mars. So we've got another probe coming up there. So lots of things to look forward to in 2016. Those are the big ones I care about, the ones that I wanted to bring to your attention. So if you've got, there's a number of ways you can get different information about this throughout the year. First of all, subscribe to this channel. Deep Astronomy I will have the monthly Future in Space Hangouts with Alberto and Harley Thronson. He's an astronomer at Goddard Space Flight Center. Every single month, we do something about the future of spaceflight, the future of astronomy, the future of both humans and science in space. So that's every month. And then every week, I do a Hubble Hangout over at Hubble Site Channel. That's a YouTube channel as well, with Carol Christian et al. Every single week. That's on Thursdays, every Thursday at 3 p.m. So you can learn about the latest Hubble science from that as well. And let me see if I can pull up some more comments here and see what we got. Thank you guys for watching, by the way. This is really cool. Technically, you guys are talking about black holes, it looks like. People call me all the time in the middle of stuff. yeah. Well, it's a little bit different when you're trying to do your own thing. Do I have a telescope? I used to have my own telescope. I was an avid amateur astronomer for most of my life. I still have an Astroscan 2001. I don't have it with me now. It's a very small 4-inch Newtonian reflector that you used to be able to buy at Edmund Scientific. I don't even know if you can still get them anymore. I also have an H-alpha telescope called a Coronado PSD for looking at the sun in H-alpha at the H-alpha wavelengths. And it's really cool because you can see active regions, filaments, sunspots, all kinds of things with that telescope. So I have that. But I used to have, for many, many years, I had a 10-inch Cave Astrola Newtonian reflector. It was an antique. It was built in the 50s sometime. And I looked at that. I used that almost every weekend when I was a kid. It was 10-inch, but it's pretty big for having as a first scope. Also, and then later on, in my later years, I bought in Meade. I actually had a Celestron C8 for many years. And this was back in the 80s when Celestron made really good telescopes. And then they kind of got away from it in the 90s, and I switched to Meade telescopes. And I bought an LX200, which was the first go-to telescope. That's where all you had to do was just set it up and tell it where it was. You just hit enter go-to, and boom, it would just find objects in the sky. It was computer controlled. Nowadays, you don't even have to tell it where it is. All you do is just set it up outside, turn it on, and it figures out where it is using GPS, and you don't even have to align the thing anymore. So that's pretty cool. And then later on, Celestron got better. I never bought another Celestron again, But they got now. There's really no difference, in my opinion, between celestron and Meade telescopes. And of course, there's a really expensive refractors like the Takahashis and the Televiews, which are really great, but I could never afford one of those, so I never had one of those. But I used to have a telescope. Now I live vicariously through the Hubble Space Telescope. I go and I just get the images straight from that. It's hard to beat the Hubble, really. Okay, so let's see. Do we have any other things? Question: why do we need to confirm the existence of gravitational waves? That's a good question. The thing is, we don't need to. We need to just confirm that they are. In fact, we need to observe them. Einstein's theory of relativity predicts that, general relativity predicts that gravity, lots of mass, actually bends the curvature of space-time. Now that's already been proven. It was proven early after Einstein first developed that theory, when they looked at the planet Mercury through a solar eclipse. Einstein predicted that if I'm right, and if a lot of mass bends the fabric of space-time, then the sun should bend it enough that we could notice. And the only way they could figure out how to notice if light rays were being bent by the sun in the early 1900s was to look at Mercury as it went behind the sun or near the sun during a solar eclipse. They had to block out the light of the sun so that they could see Mercury. It was too bright otherwise. Now, if Einstein was wrong, then the light rays from Mercury would not be bent at all. It would go straight and it would be right where it was supposed to be in the almanac. If Einstein was right, then it would be offset a little bit as it got very close to the limb of the sun, as the light from Mercury traveled a curved line around the sun and got to the telescope. So an astronomer went out and did the observations and proved him right. So we know Einstein's right, and Einstein's theories have been proven in many, many, many other ways. Time dilation, all this other stuff has actually been observed. GPS satellites actually have to compensate for time dilation up in orbit. So we know Einstein was right. But these gravitational waves are important because they are ripples in space-time. They would be like exactly analogous to dropping a rock in a pond and seeing the ripples go across the surface of the pond. In the case of the universe, let's say you had two black holes merging or two galaxies colliding, and their black holes merging would be the same thing as dropping a big rock in the universe, and it should make ripples through space-time, and we're trying to observe those. The problem is it's hard. There's everything else in the universe we got to compensate for, all the other curvatures, and it's a very, very, very weak signal. So the way they look at it is they take two lasers and they move them way, way, way far apart. And then they shine two lasers at each other, and when you do that into something called an interferometer, the laser interferes with itself, and it's extremely sensitive. It gets more sensitive the further the laser is away, and you can see very small perturbations. Well, if a gravity wave goes through that interferometer, it's going to interfere with the light signal, and you'll see it in a characteristic way. And that's all, and that's what they're looking for. Now, they've been looking for it for years and years on the ground at something called LIGO, which is the Laser Interferometry Ground Observatory or something like that, and there's two locations of those, one in Hanover, Washington, and another one somewhere else. I don't know it off the top of my head, but we've been looking for them for a long time. So far, nobody's seen one. So LISA is supposed to be launched in space. Really big telescope, very long distance between the two lasers. The problem is the funding hasn't been all that consistent, and so what LISA Pathfinder is going to do, the one I just told you about before, is it's going to launch two cubes right next to each other with a laser going in between them, and it's just going to pull apart, and they're going to look for they're going to just test the technology to make sure that it works the way they think it should. And so, but we need to see them. They've not been discovered yet, and they should be there somewhere. We just have to figure out how to find them. So that was a good question, but we really do need, I think, to look for them. Most of it is dark energy. They don't know what it is. That is true. A lot. They are trying to find a lot of the characteristics of dark energy now. That's very true. What are your opinions on the theory of information being destroyed when a black hole evaporates? Yeah, I'm not qualified enough to really say. I mean, I think Stephen Hawking had some things to say about it. I'm afraid I don't feel confident enough to really answer that one. I'm really sorry. Why did you first get into astronomy? For me, it was relativity and the connection with cosmology. That's from George Caldwell. Thank you, George. That's a good question. So here's the thing. I got into it when I was about 8. So I didn't see anybody guess what my age was, but I'll just tell you. I'm 53. I was born in 1962, so I am a product of the 60s. And so what was big in the 60s besides free love and hippies was the Apollo program. And so I was very much entranced by astronauts and going to the moon and landing there. And I got to see NASA actually land on the moon in 1969. NASA fake. Gotcha. So we did actually land on the moon, and I got to see that, and that's what got me into astronomy. And so since I was about 8 or so, I've always known what I wanted to do. The thing is, I found out what it was going to take to be an astronaut and realized that wasn't in the cards to me. So I started studying astronomy, and then it even got worse because I wanted a degree in physics because you needed to be able to, basically a physics degree with an astronomy emphasis is a really strong degree, and I wanted that, but I couldn't do math. I had math blocks. And so one of the things I'm going to do this year in these live events is I'm going to tell you the story of how I overcame my math blocks. I couldn't do math to save my life. I couldn't even do basic arithmetic. And I graduated high school that way, and I was lost for a long time, but eventually I overcame my math blocks, and I'll tell you that I'll tell you that story in some way and sometime in the future. Okay, so we've got a lot of hoaxers in there. Why do we need to confirm the existence of those? Do I believe that aliens exist? Well, or extraterrestrials. I don't know, and I don't say that lightly, but I'll give you a better answer than that. It is a question. The biggest thing that I would love an answer to when it comes to life on other planets and life in other worlds is, and I've met many evolutionary biologists, and every time the first question I ask them is this: if you have a world like an early Earth in the habitable zone, blah blah blah, it's filled with lightning and this sort of primordial ooze, all the amino acids in it, all the stuff, all the ingredients that constitute life on it. But it's not alive because it's just amino acids and stuff. How hard of a step is it to go from that, where there is no life, just amino acids? I mean, Carl Sagan and Urey, I can't recall his first name now, back in the 60s and 70s, did this experiment where you can create the amino acids from the conditions of the early Earth. You can make this big ooze yourself. Primordial ooze is easy to make. We've been doing it for a while. But it's not alive. What does it take to go from that to life, to something that is alive? I don't care what it is. Something, however you define it, something that respires, something that reproduces. I don't know what it would be. Bacteria, I'm told, are actually pretty complex life forms. So it can't say just bacteria like I used to. How hard is that step? And not a single evolutionary biologist can tell me. Now, once life forms, after that, an evolutionary biologist can't shut up. They won't be able to tell you everything, because life is pretty tenacious once it starts. And we have evidence here on Earth that it started as early as 3.5 billion, even earlier, years ago. The Earth was like 1.5 billion years old. It was still being bombarded by things at that point. And yet life existed. We have evidence that life existed there. So it's been around Earth for a long time. But how did it get here? Did it form from that primordial ooze? Did it come here from a comet? Did it get smashed here from some meteorite somewhere? That's called panspermia. And I don't know. But there's something called a great filter. And this great filter, I've done 2 videos on it already. It concerns me greatly. And it's one of the reasons why I hope we never find life on Mars. And that's the future of another video. But if life, if that step to go from primordial ooze that is not alive to something that is alive is easy, if that step is easy, then life is everywhere. I'm not talking about intelligent life, I'm just talking about life. Okay? Then life is everywhere. If that step is hard, we may be it. It's possible that we may be one of just a handful of times where this actually happened. And we may not even be the first one. It may have come to us from some other way, which makes the odds even greater. So it really is like winning the lottery. So that's a question I would like to answer. So if you ask me if I believe in aliens, I can't tell you. If I could know the answer to that question, I would say, no, I don't think so. If that step is hard. If that step is easy, then I'd say, yeah, there's probably, everything, there's probably all kinds of stuff out there. So that would be the thing I would need to have answered. Now, civilizations are a different story altogether. And the fact that we exist now means that we've overcome some great filters. Great filters are these things. It's this idea that just basically wipes out life completely. The thing that wiped out the dinosaurs wouldn't be a great filter because life still existed. It would be a great filter for a civilization or a species, but not the planet as a whole. So I'm sorry if that's not a very satisfying answer, but it really is how I feel about it. Excuse me. Okay, guys. Well, let's see. I'm still going through some of these. Wow, we've been here at this a half an hour. Can you please talk about the Fermi Paradox? Well, sure. So the Fermi Paradox, the Enrico Fermi back in the 1940s asked a question. He was the way the myth goes was that he was sitting in a conference. They were sitting at having lunch somewhere, and what is the main mission of JWST? I'll get to that in just a sec. Will it be able to observe exoplanets? The short answer is yes. Anyway, the Fermi Paradox is that Fermi goes, hey, look, the galaxy is old enough, and it's got enough stars in it that there's been plenty of time for a civilization to rise and even fall many, many times. So where is everybody? That's the paradox. Where is everybody? And that comes right back to the great filter I was talking about. We haven't seen any evidence of any civilizations, contrary to what you may see on some, even Discovery Channel, talking about UFOs. UFOs are unidentified flying objects. So if I believe in those, yes, because there's lots of things up there that are flying around you can't immediately identify. But this idea of where are other intelligent, extraterrestrial intelligences is the question that he asked. And my answer, my reason for it always comes back down to this great filter idea. Is there something out there that we have yet to face as a civilization that wipes out people, that wipes out civilizations? Does that exist? I'm sure it does. But have we already passed it? Was like the Cuban Missile Crisis our great filter and we passed it? Or do we have yet to face it? Right? Do we have some kind of gray goo issue coming in our future? So it's a scary thing to think about, but we haven't seen any other civilizations, and we should have. I mean, by all rights, by all accounts, by the numbers, if you just do the statistics, we should have seen it. Okay, so back to JWST's main mission. JWST is Hubble's successor. It's 100 times more powerful, but it's going to be placed 1.5 million kilometers away at the L2 point, way away from Earth. Once we launch it, can't go get it, can't go service it, can't do anything. But its primary mirror is huge, way, way bigger than the Hubble Space Telescope's is. And the reason that matters is that the bigger a mirror is, the more, not only more light can you collect, but the more detail that you can see. And it is hoped, and it is designed such that if there are exoplanets close enough, these are planets around other stars, that we should be able to image them directly. Now, it's not ideal. There are coronagraphs on board that block out the light of the star. There's going to be other telescopes, namely TESS and other telescopes that are going to give us a better idea of some of these exoplanet candidates. But that's one thing JWST is going to look at, directly image exoplanets. Another thing it's going to do, and this is what really gets me going about it, and this is what I'm psyched about, it's going to look back to the very first stars and galaxies in the universe. The very first stars and galaxies. And we're not talking like, among the first stars that have ever shone in the heavens. JWST is going to look at the first galaxies that ever formed, way further back than anything Hubble has ever seen. And that is going to be amazing. It's going to teach us about these very first stars and a period in the universe known as the Dark Ages. There's this period where before stars were born and after stars were being born and before the first galaxies, that we have a big, we need to be able to take a good look at. I'm sorry, I have a cold. I'm really sorry about that. But that's what JWST's main mission will be. And it's going to be run the same way the Hubble is run. It'll be run by the Space Telescope Science Institute, and they're going to be looking at various things. So astronomers will be able to decide what they want to do. Do you think we will ever be able to leave our solar system? Well, certainly not in our lifetime, but I'm not going to, you never say never. I'm not very optimistic. I mean, some of the closest planets are on order of 1,500 light years away, and unless there's something like quantum somethings that can get us there, somehow using entanglement or quantum computers or something, I'm really not optimistic that we're going to be able to. It's just the distances are so great. But never say never. I mean, I don't know. Will NASA or Elon Musk be first to Mars? Boy, that's a great question. I mean, I love NASA, I do, but let's be honest, they just don't have much money. What they do with their money is nothing short of miraculous, but I don't know. A private enterprise would be a really good thing, I hope. Eat lots of chicken soup. Thank you. What is space? What is it made of? It's made of something called vacuum energy. But I can't get into that right now. Do you think we should rather focus on propulsion and materials technologies instead of far-fetched space missions and telescopes? I think we should focus on both. I think we're not. I think they're intertwined actually. Far-fetched space missions. That's a little bit of a. I don't believe they're far-fetched. I think. Back when the Hubble Space Telescope was first conceived by Lyman Spitzer of all people back in the 50s, it was far-fetched. But here it is, nonetheless. So I think that both are important, propulsion and materials. For example, for JWST, the James Webb Space Telescope, materials had to be actually invented before they could fly it. It's made of this beryllium. The framework has this kind of beryllium alloy in it that's very light and very strong. And that stuff had to be developed first. So you can't have the JWST without material. So I think it both goes. Both goes quantum something. You like that, huh? NASA's money is stolen. What is that? Okay, well, quantum mechanics take us further with astronomy. It already kind of has with. I mean, this isn't strictly quantum mechanics, but it's particle physics with the Higgs boson, and it's helped us understand, some of the fields of astronomy like gravity. And I think what's more, and I think quantum mechanics will, especially entanglement and sorting out that, I think could help us with. Could do it. Do you think NASA is ready for human Mars missions? No, I wish they were. I watched The Martian with so much envy. I wish that was true so bad. But no, they're nowhere near ready. They've got the Orion mission, which I'm very excited about. But no, they're nowhere near ready. What about the EELT? Is that the extremely large telescope? Oh man, I'm really sorry. Why do you hope we don't find life on Mars? Stay tuned. I'm making a video on that. In fact, I'll have a hangout on it, just like this, why I think so. But first, I'm going to make a video about why I hope we don't find life on Mars. It has to do with the Great Filter, as you can imagine. Hey, Cyril, it's good to see you. Yeah, I'm just kind of playing with some technology here, and these guys have really been awesome. I don't even know how many people are watching, but it's really great that you guys are showing up. I'm really happy you're doing it. We'll keep doing more of this if you guys find it interesting. I'm sorry, I've got a cold, unfortunately. What is dark energy? Well, that's a really big question. It is this thing, whatever it is. It's just, I'll give you the short answer. That is, given that it's supposed to be responsible for the fact that the universe is not just expanding as it gets bigger, but accelerating as it gets bigger. And so for something to accelerate, you need a force. And so that dark energy is the thing that is responsible for that force. And that's really all about anybody can say about it. So people are looking. If you're interested, there are people in the at the Cerro Blanco telescope in Chile using the 4-meter telescope there. They've installed something called the dark energy camera, where they're looking at excuse me, I'm gonna have to go soon. 5,000 square degrees of sky to try and look at the large-scale structure in a way to maybe characterize what dark energy is. So it's called the Dark Energy Survey. I worked for them for 2 years, and it's a great thing. So they're trying to figure that out now. What are the best majors to study for space exploration? Well, so that's a good question, but there's a broader question I'm going to answer along with that. Not just space exploration, but astronomy. A lot of people think you've got to get a PhD to get a really good job in astronomy and in space exploration, and you don't. In fact, I think that's a dead end, because being a PhD is not only hard work for your education, but it puts you on a track that you have to move up, or you have to get out. And that's true both at the Space Telescope Science Institute, the High Altitude Observatory, the National Center for Atmospheric Research, any university you work at, it's up or out. And it's a lot of very high pressure. Now, once you get there, it's a really nice thing. Once you become a tenured professor, once you become a senior scientist, once you become an astronomer, that's awesome. But it takes a lot of work, a lot of dedication, and a lot of stress. And while the money is good when you get there, getting there is often a very high struggle. But there's another way, and it's the way I picked. Now, when I went to college and got my degree in physics, I had 2 small children. And when I graduated, I had to think about what I wanted to do. Did I want to continue and go on to grad school, or did I want to become by the way, if you want to become an astronomer and being called, Tony Darnell astronomer, then you need the PhD. So that's another reason to choose that route. But what I did instead was I was sick of school, I was sick of studying, and I already had a really good high-paying job in astronomy, so I just went ahead and said, no, I'm done. I need to take care of my kids and raise my family. So I did that instead. I did not get a PhD, but here's what I did do. I became what I call an astronomical programmer. Now, I do that as kind of tongue-in-cheek. It doesn't really talk about how good of a programmer I am, although I am pretty damn good. It's also about the kind of programming I did. I wrote code for astronomers and telescopes, and I couldn't get a job anywhere else in astronomy. Well, that's not true. I could get a job as a coder doing something else, but I really know telescopes, cameras, image processing. I know those things, and I can get a job anywhere I want easily with that skill set, and I get paid as much, if not more, than a lot of the astronomers. Certainly more than postdocs, way more than beginning astronomers. And while I won't have my ceiling is lower, my career stress is a lot less. So as far as a major, I think you need to take physics as an undergraduate. You should take physics, period. Unless you really, really, really think you're going to build things, because there's a huge market for people who can build cameras, build spacecraft, build rockets. So you'd become an engineer in that case. But in aerospace engineering probably, or software engineering if you want to write code, mechanical engineering if you want to build structures like the JWST backplane, things like that. So there's engineering, and then physics. And I say physics, don't get an undergraduate in astronomy, because that's a watered down physics degree. That's my opinion. You could disagree. But, I think a physics degree is more robust. Where I went at the University of Colorado, you could take a separate track where you could take a physics. It was called Plan 2, and they didn't have an astronomy undergrad. But I got to take things like cosmology, astrophysics 1 and 2, a bunch of astronomy courses, in addition to my physics classes. And so I had a physics degree with an astrophysics emphasis, is what they called it. And so that's what I would recommend almost anybody does. Now, then what you do is you develop a set of skills that let you do things astronomers need, and they need programmers. God, you don't know how bad astronomers code. They are awful. They don't know anything about best practices. They don't know how to write a single line of code that works, that you can actually maintain. So If you learn how to write code, that's great. If you can build a camera, learn, infrared cameras are all the rage right now. But, 10 years ago, you couldn't even build it. The technology didn't exist to build infrared detectors. But now if you can build something, then do it. So that is my advice. Don't necessarily think that just because you're interested and you really want to get into astronomy that you've got to have a PhD. That's just not true. In fact, you can have a much more rewarding career if you get rid of that altogether. Well, okay, don't choose that. I won't say that so disparagingly. And just, take another track where you are supporting astronomers, because believe me, you'll get on papers, you'll have your names on papers, you'll be able to do research. If you're good enough at what you do, you will have as much of a rewarding career without the stress. You don't have to sit on committees ad nauseum. You don't have to teach classes. You can just concentrate on your work. So that's my advice for budding astronomers if you want to try it. Okay, what if you suck at math? Well, Dan, mate, I sucked at math bad. I had math blocks up until I was in my 30s. I couldn't do math. And yet, through a story that I often tell, if you want a preview, go to DeepAstronomy.com, and I wrote an article called How I Overcame My Math Blocks. I'm going to turn that into a video. But it's on DeepAstronomy.com. It's in articles, and then you find it there. It's in there. I wrote all about it. I couldn't do it until I was 30, and I was really almost suicidal over it because I couldn't. There was nothing else I wanted to do. All I wanted to do was science and astronomy. And what do you do when the thing you want most in life, you find out you can't do? One of the things I later learned that I was mistaken about this, but one of the things I remember watching the movie Amadeus about Mozart is that Salieri, which was Mozart's contemporary, was nowhere near as good as Mozart was, and he was always wishing that he was as good as Mozart. Now that was turned out to be an inaccurate picture of Salieri, but what I took away from that movie was he was a man, Salieri, a composer or gifted musician, who wanted to be something he couldn't be. What do you do in that case? What do you do if you can't do the thing you love? You just don't have the skills. And I was really despondent over it. So there are ways around it that I'll talk about in future ones. Is there a precedent for amateur astronomers to become full-fledged professional astronomers? Of course, yeah. I mean, there's nothing to prevent you from getting your degree, becoming employed, your undergrad degree, becoming employed in the field, and then later coming on to becoming a full-fledged astronomer. The thing is, you got to have the PhD. You just gotta. You're not considered an astronomer without one. You can't qualify for jobs that call for astronomers if you don't have a PhD. You just won't get it. So if you're an amateur astronomer and you want to get into the field, I would go and try and do what I suggested. Let's say you're an amateur astronomer and your degree isn't even in science. You would need to get a skill set. I don't know what it would be. Let's say it could be web design, or it could be, usually software engineering is the best, and give astronomers a skill set they can use. Your bachelor's degree, whatever it's in, will get you in the door and get you qualified for the job if your skills are good. But to become a full-fledged astronomer, you're still going to need the PhD. And that term full-fledged professional is what I'm talking about. You can work in the field of astronomy as a professional person, just not an astronomer that way. Okay, so can you explain what redshifting will mean to the future super deep space images, please? What would the energies we'd have to see? Okay, so redshifting is this, if I understand your question right, this is from Wolvenar. If I understand your question right, it is what effect will redshift have on the earliest galaxies and stars that JWST is going to be seeing? And the reason, and what that does is, the effect it will have is it shifts the light that actually left those stars when they first were shining into a very red part of the spectrum, in this case the infrared. And that's why James Webb is being built into the infrared spectrum. When those stars were shining, they were actually very bright blue stars in the ultraviolet. But by the time that light reached us, the universe had expanded so much over the 13 billion plus years that it took to get there, to get to us, that now that light is in the infrared. And so you need to look in the infrared to see it. And that's what JWST is going to be do. Okay, so I think I'm going to have to stop here, guys, because my throat is going. But wow, I'm really pleased with how many of you showed up, and I want to thank you so much for taking the time out to watch my humble little thing. It's been 50 minutes. I can't believe I've been rambling for 50 minutes. Okay, so to review the things I'm excited about for 2016. The progress with JWST. They're building it at Goddard Space Flight Center now. They're going to, like I said, they're going to be putting together the primary and the secondary mirror components. They're going to attach it to the ISIM, the Integrated Science Instrument Module, which is a big, where all the science is going to sit on JWST, as well as the backplane. And then they're going to connect it all to the sun shield, which is this big reflective surface. If you ever want to learn about what JWST is doing, go to jwst.nasa.gov and you'll see it, as well as updates on what's going on. Also in March, another thing I'm excited about, Lisa Pathfinder will start returning science. I'll have a future in space hangout on that with Alberto Conti and the members of the science team to talk about what they're learning. So look for that in probably mid-March. The Juno mission reaches Jupiter in July, which will be really cool. The Schiaparelli mission goes to Mars in March. And those are the big items I think are important. There's a lot more going on, but that's just what I think is important, and that's all I care about. All right, folks. Well, I'll take one more quick look around, see what anybody's. Eat soup. Thank you. Boy, that came on me all of a sudden. I didn't realize talking so much would make me do it. Drink a beer. That is an even better idea. So thank you guys for watching. This has been a lot of fun. Give me some feedback. I'm at DeepAstronomy on Twitter. Leave comments on this video. I'll read them as time goes on. And let me know what you think of these things. If you like them, I'll keep doing them and at some frequency. I feel kind of like I'm rambling. Because I'm by myself, I really can't do a lot of visual stuff because I can't multitask all that well. Wirecast lets me do some things pretty easy. But really, I like this interaction where you guys and I are talking, and I can just, kind of get you guys my advice or my thoughts, my experiences on various things. And I feel really strongly about what I said with the career stuff. So I hope that helps some of you guys. All right, folks. Well, that's it for this week, or that's it for this time around. I will see you again when at some point. Let me know how you think. Oh, this week, 2 things are happening on Deep Astronomy, this channel. Tomorrow, I'm releasing a new video written by a student of mine on the Transiting Exoplanet Survey Satellite called TESS. That's coming out tomorrow. It'll also feature some stuff on JWST. I'll release it tomorrow, so look for it on the channel here. Also, if you're a Patreon subscriber or supporter for SpaceFan News, I'll have SpaceFan News episode out tomorrow on Patreon. If you don't support it that way, it'll come out. You'll see it on Friday. So Friday, the next version or the next episode of SpaceFan News will come out. And if you are out there and you have supported me on Patreon, I want to thank you so much for doing that. It really helps me to be able to get some time and equipment to be able to do these kinds of things. In fact, I bought a Wirecast with some of the money that you guys had supported me with. So thank you very much for doing that. If you'd like to become a supporter, it's at patreon.com/SFN in all caps. So if you feel like it, thank you. If not, no worries. It's not going to change whether I do this or not. Okay, folks, thank you all for watching. And as always, keep looking up.